Hello. In the previous units we have seen how an activity-dependent learning rule such as STDP can lead to out-of-control growth of synaptic weights in a neural model. But we know that such unlimited growth is unfeasible in the brain, in fact undesirable for healthy neuronal functioning. In the last few decades, there have been experiments that demonstrated the existence of various forms of homeostasis in neurons that could potentially compensate for such self-enforcing rules, such as STDP. One such homeostasis is called synaptic normalization, and it's inspired by this study here. Simply said, synaptic normalization scales down or scales up a whole group of weights from synaptic inputs if the sum of those weights exceeds or falls short of some threshold or some desired sum, which we call W total. Let us take this example here. We have a neuron with some inputs. The sum of these weights equals exactly W total. Everything is fine. Now, STDP might now selectively strengthen one of these weights. Of course, now the sum exceeds W total. Synaptic normalization then acts on the synaptic weights themselves in a group-like manner, scaling all of these weights down, such that the sum again equals W total. Now note that even though the sum is the same as before, the difference that was caused by STDP is maintained between these synapses. Now, this rule, of course, ensures that you don't get unlimited growth of a synaptic weight, because a single weight can never exceed W total by itself. The biological basis of this synaptic normalization very likely lies in the limitation of postsynaptic resources, for example, receptors for neurotransmitter. The rule here is formalized in this equation, so you can see that synaptic weight J, that is part of some group of weights, at some time point t plus 1, is equal to the weight at the previous time point, scaled up or down by this factor. And you can see the factor will be larger than 1 if the sum falls short of the target, and will be smaller than 1 if the sum exceeds the target. Let us now see how synaptic normalization affects the competition between input groups that have STDP in their synapses.